Hi, it's time for the math easy solution. We're going to discuss further into integrals and areas between curves, and go over further into the example series and go over part 4 of the examples. Basically, I'm going to go over this example, which states find the area of the region bounded by the curves y equals sine of x, y equals cos x, and x equals 0, and x equals pi over 2. So first thing to do is graph these out. So we'll just graph it out. Okay, and now the graph of the sine curve, like I showed in my earlier video, is just something like this, etc. But we only need it from just from 0 to pi over 2, and at pi over 2, which is at 90 degrees, we know that this value is equal to 1 right here. And this is at pi over 2, and this is our sine of x function. And now our cos of x function, it's the same thing as the sine except shifted to the left by pi over 2. So it actually starts off at 0 like this, and then so it's at 1 here, and then it goes down to 0, etc. And it goes something like that. I'm not gonna continue on there. Actually, then it goes something like that. Anyway, so then at this point it's at 0, and now there's an intersection point right here. Because remember, this cos of x function, it's the exact same as sine of x except shifted to the left. So then by symmetry, this is pi over 2. This is just going to be pi over 2, well, in half, and this is going to be pi over 4, this intersection point. So now we have two areas though, so A1 and A2, and we're supposed to find the area between the two curves. But as you can see, initially from this region we have cos of x is greater than sine of x. But from this region right here, we have sine of x is greater than or equal to cos of x. That's in between there. Put the equal there too. So basically, to solve this, we need to do like I showed in my earlier video and find the integral, but in terms of absolute value. So the integral, or the area, is going to be equal to, basically the total area is going to be equal to the integral of 0 to pi over 2 of the absolute value of cos of x minus sine of x dx right here. And now when we look at the absolute value in terms of this area right here, this is just going to be cos x minus sine of x, so that's just going to remain positive. But on this A2 area right here, this region, so on this region we have to flip it, so it will be sine of x minus cos of x. So this is the same thing as equaling to from 0 to, or else I just write it down here, equals to 0 to pi over 4. So this is the first region. This is going to be cos of x minus sine of x, in bracket dx right here, plus now the second area. This is from pi over 4 to pi over 2, and this is going to be, just flip it around, sine of x minus cos of x. We flip it so that it's positive right here, dx, because sine of x is greater than cos of x. So now that we have this, we can begin solving the integral of this. Now the integral of cos of x is just sine of x, so we can just put that down right here. You can see the proof of this in the video link below. And now minus the sine of x, the derivative is, oh no, the integral of this is negative cos of x. So we have to put a negative, so it's going to be positive. Because negative cos of x derivative is going to be, well, sine of x positive. And now this is from 0 to pi over 4, plus, I'll fix this pi up, so it looks like that. And then plus, now this one, same thing, the integral of sine of x is going to be negative cos of x. And then minus this integral of cos of x is just sine of x, so sine of x, and keep the negative there. And this is from pi over 4 to pi over 2. And now when we plug these values in, well, we know that, I'll just, before I get to this one, I'll just make a little, basically a little section to answer when we have sine of pi over 4 and cos of pi over 4, like I showed in my earlier video on exact trig ratios. If we draw a triangle with pi over 4 right here, these are going to be, this is 45 degrees in degrees. This is going to be a 1, and then this is going to be square root 2. or using just Pythagoras theorem, get 1 squared plus 1 squared, all square root is going to be square root of 2. So then both of these is equal to, well, opposite over hypotenuse or adjacent over hypotenuse. They both equal to 1 over square root of 2. Let's write that better. So just go back to this now. When we plug in our answers, plug in pi over 4 in both, we get basically equal to, this is going to be equal to 1 over square root of 2 plus 1 over square root of 2 minus, now when we plug in 0 in both, sine of 0, that is basically when we look up this function, sine of 0 is 0, cos of 0 is 1, and then opposites at pi over 2. So we get basically sine of 0 is 0 plus cos of 0 is 1. And now we add the second area, this one right here, negative cosine of pi over 2, that's just going to be, well, I mean pi over 2 right here first. Yeah, no, not pi over 4. So basically plug this into this. So again, at pi over 2, cos of pi over 2 is 0, but sine of pi over 2 is 1. So we get 0. Now minus sine of 0, that's just going to be, well, 1. And now this is going to be, let's see, we subtract this now by when we plug in pi over 4. So when we plug that in, that's just going to be, well, negative 1 over square root of 2, and then minus 1 over square root of 2. So we get basically this area right now. Let's remove this bracket, we don't need it. So now we have this, and then we just add up everything we get right here. This is going to be 2 over square root of 2 minus 1. Now this is just a minus 1. And now this one's minus, add these up. It's going to be positive 2 over square root of 2. And now add these two up, we'll get basically 4 over square root of 2 minus 2. Or simplify this both and multiply it by square root of 2 over 2. Some people like writing it like this. We'll get basically 4 times by square root of 2 over the 2's cancel. Well, square roots cancel, so we'll have 2 minus 2, and this equals 2. Basically, just divide it out, 2 square root of 2 minus 2. This is just extra simplification that you don't need to do that. Some people just like writing the square root above the denominator, but this is the correct answer as well. And also, just a note, as you can see from this, is we're just basically doing the same thing. Both of these sides have pretty much the same answers, but there's a negative, but there's a negative side over here. Actually, there's a negative, but they're both the same thing. So we're adding the same values twice, and also when we go back up, we see that these two areas are symmetric. Yeah, so if they're symmetric, what we could do is just solve the integral of one of them and multiply it by 2. So we could have saved time. Yeah, we could have saved time and used symmetry to simplify the area. So basically the area is equal to 2 times a1 or a2, and this just equals to 2 times 0 to pi over 4, not pi over 2, this is just the halfway point of basically cos of x minus sine of x, and now this is dx right here, and we'll basically get square root 2 minus 1, and then times by 2. So basically we could have simplified it by writing the equation out like this, and it would have been much easier. So it's always important to note any symmetry you find and try to simplify your functions. Anyways, that's all for today. Hopefully you learned from this video, and like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.